Welcome back to today's session. In the previous session, we learned one of the network analysis technique called CPM, that is the critical path method. Today, we will be looking into another network analysis technique called PERT, that is Program Evaluation and Review Technique, or it is also called Project Evaluation and Review Technique. See, the major difference between your CPM and PERT is CPM considers deterministic time estimates and PERT considers probabilistic time estimates. So PERT is far more realistic, far more practicable when compared to CPM. So I will tell you regarding this in detail in the course of learning PERT. See, PERT is a network analysis technique used to estimate the project duration when there is a high degree of uncertainty about individual activities and the activity duration estimates. PERT uses probabilistic time estimates based on optimistic, most likely, and pessimistic estimates of the activity durations. So now you might have a doubt, what is this optimistic, most likely, and pessimistic time estimates, right? So why do we consider probabilistic time estimates? See, if at all a task is given, let me consider it was feasibility analysis or feasibility study. So can you tell me exactly within 2 days you will be able to finish the feasibility study? Maybe all the data that you are looking for, if at all it is made available to you very easily, you might be able to complete it within 1 day, though I given you a deadline of 2 days. But whatever data you are looking for, if at all nothing is available to you and you have to search for it quite a lot, you have to spend more time performing the feasibility study. Maybe within 2 days you may not be able to complete. You might require 3 days or maybe 4 days. So can you exactly specify that the duration for this activity is 2 days? So such deterministic time estimate will become tough. Therefore, we consider probabilistic time estimates. First one being optimistic time. This is the time required under optimal conditions. That is, it is the smallest time taken to complete the activity if everything goes on well. See, everything happens correctly and you are able to finish the activity quite early, quite fast. Then we call it the optimistic time. It is the smallest time required for the activity to get over. We denote this estimate as either A or TO, time optimistic. Okay. Next is the pessimistic time. This is the time required under worst conditions. It is the longest time that an activity would take if everything goes wrong. See, let me consider I have a project group. Let me say I have 5 programmers in it. So with the 5 programmers working together, maybe I expect a particular project coding phase to get over within 10 days. Assume 2 of the programmers were detected for corona positive They have to be isolated, they have to be removed from the project. One more fellow is suffering with flu. One fellow's laptop isn't working. His resources are not working. Then can you expect to complete the task within 10 days? So everything has gone wrong here. So obviously the time will get extended. And out of this, many of the things are not in our hands. We cannot control it many a times. So obviously the activity duration will get extended. Such a time estimate is called pessimistic time estimate. The worst possible, longest possible duration that is required for an activity to be completed. We denote it by either B or TP, pessimistic time. The third one being most likely time. So this considers most probable length of time that will be required for the activity. This assumes normal delays. See, not every time everything goes well, and not every time everything goes wrong. So some normal delays are expected. So I assume that only normal delays happen. And what will be the time estimate or the time duration required for the activity? That is called the most likely time estimate. We denote it by M or TM, most likely time. Okay? Hope the concept is clear. So using these three time estimates, TO, TP and TM, right? Using optimistic, pessimistic and most likely time estimate, we find something called as an expected time estimate, which is considered for the project scheduling or project management. Okay, so we calculate TE, expected time, which is given by the formula TO plus 4TM plus TP whole divided by 6. The logic that we are using here is 6 times if activity is done, maybe one time everything goes fine and one time everything goes wrong, but remaining 4 times just the normal delay happens. So such time estimates average is taken. So I am performing it 6 times, therefore once optimistic, once pessimistic, 4 times most likely. Add up all these time durations divided by 6, that I will consider as expected time estimate. So T is expected time, TO is optimistic time, TM most likely time, TP pessimistic time. This formula you should remember. It is quite easy. See, 1 plus 4, 5, 5 plus 1, 6. So total you are supposed to get 6 on the numerator and 6 on the denominator. Out of the 6 on the numerator, TO and TP are with coefficient 1 each. So TO plus TP, remaining is 4 units. So that will be TM, 4 TM. Okay? So you will have to remember this formula. And next, we will move ahead. You will have to calculate a variance. See, whenever we are considering probabilistic estimates, the possibility of variance will always be there. See, I will calculate a particular estimate or the project duration to be, let me say, 30 days. So it will not be exactly 30 days. It will be 30 days plus or minus some value, plus or minus maybe 2 days. So I might finish within 28 days or I might finish it by 32 days. So that variance also has to be computed. So for computing the variance of every individual activity, for individual activities, the variance is computed using the formula sigma square equals Tp minus To by 6 whole square. Denominator is still 6. But here I am not considering most likely. I am considering the both extremes. One is the best time, one is the worst time. So I am taking worst time minus best time divided by 6 whole square. Okay. So variance sigma square is Tp minus To by 6 whole square. So where sigma square is variance, To is optimistic time and Tp is pessimistic time. Okay. Then we are supposed to find out the probabilities as well, right? So for finding the probabilities, we make use of one more formula, which is Z equals specified time minus path mean. Path mean is nothing but your expected project duration, right? The expected project duration, we term it as path mean. So Z is specified time minus path mean divided by path standard deviation. Okay. So Z we are considering because Z indicates the standard deviations of the path distribution. The specified time is beyond the expected path duration. So I know that you people will not understand this statement. For your understanding, see, we are going with an assumption that your project follows normal distribution and Z is indicating the standard normal variate, right? Z is indicating standard normal variate, SNV. Okay. So we are trying to consider SNV and try to estimate the probabilities by assessing the area under the normal curve. So this is similar to whatever we had solved normal distribution problem in your third sem, statistical analysis. So same type here also we will be looking into the table value. Like the normal distribution problem that we had solved earlier, we will be solving here as well. Okay. So now a brief algorithm or the steps or the procedure of solving a PERT problem. So step 1, list all the jobs, draw the network diagram showing the relationship among the activities. And for every activity you will be given 3 time estimates: optimistic, pessimistic and most likely. So what we are supposed to do, compute the expected duration of each activity using the formula TE is equal to TO plus 4TM plus TP whole divided by 6. After that, compute the early start, early finish, late start, late finish and the total float for each activity. That means perform forward pass computation, perform backward pass computation and identify the critical path. So step 4 is identify the critical activities and the critical path for the project. Then step 5, compute the project length variance, the overall project variance. First you had computed individual activity variances. Now I am computing the overall project variance. So the overall project variance sigma square is the sum of the variances of all the critical activities, right? So on the critical activities, on the critical path, whichever activities are found out, for those activities whatever variances we have got, those variances will be added, and for that we take a square root which gives us the standard deviation of the project length. Okay. Then step 6, calculate the SNV, standard normal variate Z. For that we will use the formula which we have already specified, where Z is equal to specified time minus path mean divided by path standard deviation. Then step 7, using the normal curve, we can estimate the probability of completing the project within the specified time. Okay, this is the steps involved or the procedure involved in solving a PERT problem. So shall we take a PERT problem and try to solve it? So this is the problem. The following table shows the jobs of a project with their time estimates in days. Draw the network diagram, determine the critical path, also find the probability that the project is completed in 40 days. Okay, so within 40 days, I will complete the project. For that, we are supposed to find out the probability. So here what they have done is, for every job, 1 to 2, 1 to 6, 2 to 3, 2 to 4, 3 to 5, 4 to 5, 6 to 7, 5 to 8, and 7 to 8, they have given us three time estimates. One is the optimistic time, most likely time, pessimistic time. So obviously you know that optimistic time will be less than or equal to most likely time will be less than or equal to pessimistic time. Okay, so just have a look. So for this particular time estimate 1 to 2, for this particular activity 1 to 2, the time estimates might go as 1 as the optimistic duration, 1 day, and 7 days for the most likely scenario, and maybe 13 days in the pessimistic scenario. So similarly for all other activities, 1 to 6, 2 to 3, 2 to 4, 3 to 5, 4 to 5, 6 to 7, 5 to 8, and 7 to 8, the time estimates are as given below. It will be 2, 5, 14, 2, 14, 26, 2, 5, 8, 7, 10, 19, 5, 5, 17, 5, 8, 29, 3, 3, 9, 8, 17, 32. So whenever a problem is given, in case of PERT, first thing that you need to look into is the validity of the data given. So how do you check the validity of the data given? Always your pessimistic time should be more than your most likely time, or it should be at least equal. It should never be less. Okay? And similarly, most likely time should be either equal or should be more than optimistic time. It should never be less. So that you will have to look in all the data. So once the data is correct, you can go ahead for computing the expected time. TE is equal to TO plus 4TM plus TP by 6. So this computation you can do. So all the given jobs and their time estimates I have written. So I have taken 1 plus 7 fours, 28 plus 13. So 13 plus 28 plus 1 is 28 plus 1, 29, 29 plus 10, 39, 39 plus 9, 42. So it is 42 by 6. So 42 by 6 is 7, right? So individually for every activity, by using that method, I will find out the expected time. So 2 plus 5 into 4, 20 plus 14 divided by 6, I get a 6. 2 plus 4 into 14 is equal to, which is 56. Then plus 26 divided by 6 is 14. Then 2 plus 5 fours are 20 plus 8 divided by 6 is 5. 7 plus 10 fours are 40 plus 19 divided by 6 is 11. Then 5 plus 5 fours are 20 plus 17 divided by 6, I get a 7. 5 plus 8 fours are 32 plus 29 divided by 6, I get 11. 3 plus 3 fours are 12 plus 9 divided by 6, I get a 4. Then 8 plus 17 fours are 68 plus 32 divided by 6, I get 18. So once I have calculated the expected times, that will be the duration that I will be using in the network diagram. So for the given jobs 1 to 2, I am supposed to have an activity with duration 7. Then I have 1 to 6, 1 to 6 with duration 6. Then I have 2 to 3 and 2 to 4. So 2 to 3 one activity, 2 to 4 one activity. Durations 14 and 5. Then I have 3 to 5 and 4 to 5. So 3 to 5 and 4 to 5 with durations 11 and 7. Then I have an activity 6 to 7 with duration 11. Then I have 5 to 8 and 7 to 8. Two activities with duration 4 and 18. So your network diagram is now ready. What next? So obviously forward pass and backward pass computation. Right? So rectangle and triangle I put. So initially for forward pass I am initializing it to 0. So 0 plus 7 I get a 7 here. 0 plus 6 I get a 6 here. Then 6 plus 11 17. Here 7 plus 5 is 12. 7 plus 14 is 21. Okay. Now when I am supposed to compute here, there are two possible inputs. 21 plus 11 I'll get a 32 and 12 plus 7 I'll get a 19. So the max of it is 32. That is computed. Then 32 plus 4 is 36 is one option. 17 plus 18 is a 35. So out of 35 and 36, 36 is maximum. I have written that. So whatever the value that I get here will be the initial value for the triangles. So I am copying 36. So 36 minus 4 will give a 32. 36 minus 18 gives a 18 here. So from here 18 minus 11 I will get a 7. 32 minus 7 I get a 25. 32 minus 11 I get a 21 here. Now when I come here I have two inputs. So 21 minus 14 I get a possible 7 and 25 minus 5 I get a possible 20. So out of 20 and 7 which is minimum? 7. So I make a note of 7 here. Once again here I have two possible inputs. 7 minus 7, 0 is one input. 7 minus 6, 1 is one possible input. So I am supposed to take the minimum. So minimum out of 0 and 1 is 0. Right? Now looking at the diagram, find the critical path 0 0. Then I have a 7 7 here. Then I have a 21 21 here. Then I have a 32 32 here and a 36 36 here. So my critical path will be from 1 to 2, 2 to 3, 3 to 5 and 5 to 8. Okay. So the critical path has been identified and highlighted. Now what will be the expected project duration? So the project duration is 36 days. So expected project duration is 36 days. Now find out the possible variances of individual activities. So for every activity I am supposed to find out the individual variance. Sigma square using the formula Tp minus To by 6 whole square. So it is 13 minus 1, 12. 12 by 6 is 2. 2 square is 4. Then 14 minus 2 is 12. 12 by 6 is 2. 2 square is 4. 26 minus 2 is 24. 24 by 6 is 4. 4 square is 16. 8 minus 2 is 6. 6 by 6 is 1. 1 square is 1. 19 minus 7 is 12. 12 by 6 is 2. 2 square is 4. Then 17 minus 5 is 12. 12 by 6 is 2. 2 square is 4. 29 minus 5 is 24. 24 by 6 is 4. 4 square is 16. Then 9 minus 3 is 6. 6 by 6 is 1. 1 square is 1. 32 minus 8 is 24. 24 by 6 is 4. 4 square is 16. So individual activity variances I have got. Now the project length variance has to be computed. So what is the project length variance? So the sum of the variances of the activities on the critical path. So critical path is 1 to 2, 2 to 3, 3 to 5, 5 to 8. So 1 to 2, what is the variance? 4. Then 2 to 3, what is the variance? 16. 3 to 5, what is the variance? 4. 5 to 8, what is the variance? 1. So I am supposed to add these variances. So it is 4 plus 16 plus 4 plus 1. 16 నాకు 20 25 25. So I get 25 as the project length variance. So if the project length variance is 25, what is the project length standard deviation? So it will be square root of the variance. So root of 25, which is 5. So I have calculated the expected project duration to be 36 days. Then the project length standard deviation as 5. Now we have the task of computing the probability. So they have asked us to find out the probability that the project will be completed within 40 days. So probability that the project will be completed in 40 days is given by P of probability of Z less than equal to D. So we know the formula, standard normal variate, specified time minus path mean divided by path standard deviation. Specified time, what is the duration they have specified in the problem? 40. Path mean is the expected project duration. So I have computed it to be 36. So I get 40 minus 36 divided by path standard deviation. We have calculated the path standard deviation here, 5. So it is 40 minus 36 by 5. 40 minus 36 is 4. 4 by 5 is 0.8. So now the probability can be estimated using a normal curve because I am considering the standard normal variate Z. So probability of Z less than equal to D is written as probability of Z less than equal to 0.8 because D I have calculated it as 0.8. So where does 0.8 appear? See, here is the middle value 0. All the values behind it is negative. And the values after 0 are positive. So 0.8 must appear after 0 only, right? So it must be some value after 0, 0.8. So for this I am supposed to look into the table value, right? If you have the table with you for area under the normal curve, you can use that only. I have used a simplified table here. So where I take the Z value and its corresponding probability is given. So I am looking for the Z value 0.8. Its probability is 0.7881, right? So P of Z less than equal to D will be 0.7881. When I write it in percentage, it will be 78.81%. So the conclusion that I write is the probability that the project is completed in 40 days is 78.81%. Any doubt with the problem? Isn't it simple? Very simple, right? So shall we solve one more problem? Fast, quick solving one more problem? Right. The following table shows the jobs of a project with their estimates in days. Draw the project network diagram and determine the critical path. Also find the probability that the project is completed in 30 days, and one more probability that they have asked us to compute is project is completed in 25 days. Okay. So the jobs are 1 to 2, 1 to 3, 2 to 4, 3 to 4, 4 to 5 and 3 to 5. So the time estimates are 2, 5, 14, 9, 12, 15, 5, 14, 17, 2, 5, 8, 6, 6, 2, oh sorry, 6, 6, 12, 8, 17, 20. Okay. So based on that, I have drawn a project network here. What happened to the mouse pointer? Where has it gone? So I'll compute the expected time, which will be 2 plus 5 in 5 4s are 20 plus 14 divided by 6, which will be 6. Then 9 plus 12 4s are 48 plus 15 divided by 6 will be 12. 5 plus 14 4s are 56 plus 17 divided by 6 will be 13. Then 2 plus 5 4s are 20 plus 8 divided by 6 will give me 5. Then 8 plus 17 4s are 68 plus 20 divided by 6 gives me 16. Then 6 plus 6 4s are 24 plus 12 divided by 6 gives me 7. Okay, individual expected times are calculated. Now I am drawing the network diagram. So the network diagram 1 to 2, I am joining a line with duration 6. Then 1 to 3, I have an activity with duration 12. Then I have 2 to 4 with 13. So 2 to 4 with 13. Then 3 to 4 with 5. So from 3 to 4 with 5. Then 3 to 5 with 16. 3 to 5 with 16. Then 4 to 5 with 7. So from 4 to 5 with 7. So my network diagram is ready. So with the available network diagram, what are we supposed to do? Forward pass computation and backward pass computation. In the forward pass computation, starting value is 0. So 0 plus 6, I get a 6 here, and 0 plus 12, 12 I get here. Then here 6 plus 13 is 19, or I get 12 plus 5, 17, which is maximum 19. Then for this I get 12 plus 16 is 28, or 19 plus 7, 19 plus 7, 26. So 28 and 26. 28 is maximum, so I write 28. So that will be the initial value for the backward pass computation. So 28 minus 7, I get a 21 here. So 28 minus 16 is a 12, and 21 minus 5 is a 16. So out of 12 and 16, whichever is minimum has to be written. So 12 is minimum. Then here 21 minus 13. 21 minus 13 is 8. Okay. So now out of these two, 8 minus 6 is a 2, and 12 minus 12 is a 0. So whichever is minimum has to be written. So that will be 0. So now looking at the network diagram that we have constructed, find the critical path. I have a 0, 0 here, I have a 12, 12 here, and I have a 28, 28 here. Here the triangle and rectangle are not matching. Therefore, leave this, the remaining part will become my critical path. So 1 to 3, 3 to 5 is the critical path. Critical path is 1 to 3, 3 to 5. So the expected project duration is 28 days. Okay. Now go ahead computing the probabilities. So, before probabilities, I am supposed to find out the standard deviation. So for computing the standard deviation, individual activity variances I am supposed to compute. So individual activity variances will be 14 minus 2 is 12, 12 by 6 is 2, 2 square is 4, 15 minus 9, 15 minus 9 is a 6, 6 by 6 is 1, 1 square is 1, 17 minus 5, 12, 12 by 6 is 2, 2 square is 4, then 8 minus 2 is a 6, 6 by 6 is 1, 1 square is 1. Then 20 minus 8 is a 12, 12 by 6 is 2, 2 square is 4. Then 12 minus 6 is a 6, 6 minus, 6 by 6 is a 1, 1 square is 1. So the critical path we had identified was 1 to 3, 3 to 5. 1 to 3 variance is 1, 3 to 5 variance is 4. So add these two variances. So 1 plus 4 is a 5. So the project length standard deviation is root of 5, which is 2.2360. Okay, 2.2360. So we are supposed to find out the probability now. So probability of Z less than equal to D. So D is the specified time minus project path mean by divided by path standard deviation. Specified time is 30 days for the first sub question, and the expected project duration we have calculated it to be 28 days. So it will be 30 minus 28. Path standard deviation is 2.2360. So I get 2 by 2.2360, which is 0.8944. So I am supposed to find out the probability for Z less than equal to 0.8944. So look at the table. With the table you have, you will get a very accurate answer. But I am using a simple table. Exact point 8944 I don't have here. The nearest value I am taking, the nearest value for 0.8944 is 0.88 here. So for 0.88, the approximate probability is 0.8106. So P of Z less than equal to D is 0.8106. So I am considering 81.06% as a probability. So the probability that the project will be completed in 30 days is 81.06. So when you look at your table, you might get a far more accurate result. You might maybe get around 85% something, right? Around 85%. No, not even 85%. Around 82% you will get, right? You will get the value approximately nearer to 82%. Okay. Now the second sub problem, where they have asked us to find out the probability that the project is completed in 25 days. So P of Z less than equal to D. D is equal to specified time minus path mean divided by path standard deviation. Specified time is 25 days. So 25 minus project duration that we have calculated is 28. So 25 minus 28 divided by standard deviation, 2.2360. So 25 minus 28 is minus 3. So minus 3 by 2.2360, I get a minus 1.3417. So find the probability for minus 1.3417. Minus 1.34 nearest value is minus 1.32 in the table that I have. So the nearest value that I am getting is 0.0934. So table value 0.0934, so which will be 9.34%. So when you look at the accurate results, it will be somewhere between 8.5 to 9%, right? It will be somewhere between 8.5 to 9% accurate value. Here I am taking an approximate by taking the nearest value. So I get 9.34%, right? Here I am showing you a different graph because minus 1.3 appears behind 0. This is obviously the 0 position, right? This is the 0 position. So your area should be behind 0. So the curve is written where I mark a point behind 0. So the probability that I get is 9.34%. The conclusion is the probability that the project will be completed in 25 days is 9.34%. Hope you people have understood the concept. Wasn't it simple? If at all you have any doubts, you can just post it on the classroom platform. Thank you for your patient listening. Till the next session, have a nice time. Enjoy. Thank you.